Good morning to all. Today's topic is DFS graph traversal. DFS means depth first graph traversal. Actually, there are two types of graph traversals. One is called as BFS, another is called as DFS. So in BFS we called as breadth first search, DFS is called as depth first search. So we called as a depth first search graph traversal. So by using these graph traversals, we get the spanning tree from a graph. The purpose of graph traversal is we get the spanning trees from a graph. The major difference of graph and tree is the graph will contain cycles, while in the case of trees will not contain cycles. The purpose of this graph traversals is to get the spanning trees. We can visit all the nodes of a graph and we can get the spanning tree from a graph. So what is the procedure? So what is the procedure for graph traversal? What is the procedure for be a DFS graph traversals? What is the procedure? So the procedure for DFS graph traversal is start from the first node. So you have to start from the first node. Always you have to start from first node. After our first node, so push the first node into the stack. Pop top of the element from the stack and visit the node. Push all its adjacent vertices into the stack which are not visited. We push all its adjacent vertices which are not visited and not in the stack. Repeat steps 3 and 4 until stack is empty. So this is the process we are used in DFS graph traversal. So what is the procedure? You have to start from first node. So you take any node in the first node. You have to start from the first node, push the first node into the stack, then pop the top of the element from the stack and visit the node. Pop top of the element from the stack and visit the node. Push all its adjacent vertices into the stack which are not visited and not in the stack. You have to repeat these steps 3 and 4 until stack is empty. This is the procedure for DFS graph traversal. So push the node into the stack and pop the top of the element from the stack. So we continue this process until to visit the all the nodes of a graph. So we go for one example. Suppose this is the graph. A to B, B to C, A to D, again B to E, B to C, B to D. Suppose this is my graph. A, B, C, D, and E. So what is the graph traversal for this graph? What is the BFX graph traversal for this graph? Step 1. Push node A into the stack. So we have push node A into the stack. But I will assume first node in the stack. So after pushing the first node into the stack is like this. Push top of the node into the stack. So A is the first node, we push A into the stack. So let us assume that this is the stack. Push node A into the stack. Step 2. Pop node A from the stack and visit the node. Pop top of the node. A is the top of the node. So you have to pop A from the stack and visit the node. So pop top of the node from the stack and visit node A. Step 3. Push all the adjacent vertices of A into the stack. So what are the adjacent vertices of A? So what are the adjacent vertices of A? What are the adjacent vertices of A? A adjacent vertices is B, D, and E. B, B, D, and E. These are the adjacent vertices of A. So push all the adjacent vertices of A into the stack. What are the adjacent vertices of A? The adjacent vertices of A is B, D, and E. So we have to push D, D, E into the stack. pop top of the element from the stack and visit the node. So you have to pop top of the element from the stack and visit the node. So what are the top of the element of the stack? What is the top of the element? A and E. Step 5. Push all the adjacent vertices of node A into the stack. Push all the adjacent vertices of node E into the stack. So what are the adjacent vertices of node E? So the adjacent one node vertex of node E is C and E, D. D is already there, so we have to push C. Step 6. Pop top of the element from the stack and visit the node. So then what are the nodes? Print we have the A already visited, E is already visited, and C. Step 7. There is no unvisited adjacent vertices of node C. So pop node D, pop node D from the stack and print the node. So when you print A, E, C, and D. Step 8. There is no adjacent vertices of node D. So pop top of the element from the stack and print the node. So print A, E, C, D, and B. All the vertices graph is listed, and finally the BFS, the DFS graph traversal for the graph is. So what is the final A, A, E, C, D, B. This is the final graph traversal, BFS graph traversal for this graph. So this is the way. So we print. So this is the procedure. So this is the process we are using for DFS graph traversal. So what is the procedure? So you have to start from the first node, push the first node into the stack, pop top of the element from the stack and visit the node. Push all its adjacent vertices into the stack which are not visited and not in the stack. How to repeat steps 3 and 4 until stack is empty. So for example, this is my graph. I will push node A into the stack. Then I will pop A and print the node. Then push adjacent vertices of A. The adjacent vertices of node A is B, D, and E. So I will push all these nodes into the stack B, D, E. Then I pop top of the element. What is the top of the element? E. So pop top of the element from the stack and visit the node. So I will visit A. Then what are the adjacent vertices of E? So the adjacent vertices of E is A, D, and C. A and D is already visited, so you have to push C. Push C. Again pop top of the element. So what are the top of the element? C. So pop. After pop the C, the stack is B and D. Again you have to pop top of the element. So after pop the top of the element, the stack is D. So after again we have the B. So yeah. So like this we can traverse the DFS graph traversal. So this is the procedure for DFS graph traversal. Then go for algorithm. How to write an algorithm for DFS graph traversal. So what is the procedure to write an algorithm? So first of all, I cannot visit any node. So make it is all visit of 0. So you have to take top of the element always. You have to, if there is any if there is an edge adjacent, who will say that adjacent vertex if there is an edge, so the value is represented by 1. If there is no edge, the value is represented by 0. If there is an edge, adjacent vertex means edge. If there is an edge, you have to push the element into the stack. If there is no edge, so do not push the element into the stack. So now we'll discuss algorithm for DFS graph traversal. So what is the algorithm for DFS graph traversal? So let us we have the first I will visit void. Return type of the function is void. The return type of the function is void. So class name is graph. The method is DFS. We have the graph in always a graph is represented by a two-dimensional matrix, adjacent matrix. That's way n is the graph is represented, so we call it as adjacent matrix. Adjacent matrix is a square matrix. That's way DFS graph traversal. So first I will visit node 1. First node I will visit. I'll make it as first node as a visit node. So visit of 0. So first I will visit all the vertices. I'll make for I equal to 0, I less than n, I plus plus. Let us assume that there are n vertices. First I cannot visit any vertex, that's way. So visit of I equal to 0. Visit of I 0 indicates there is no adjacent vertices of the graph. So initially we cannot visit any graph, that's way. First I will visit 0 equal to 1, v equal to 0. So first I visited the graph 0, v equal to 0, v equal to 0. While I less than n, so let us assume that there are n vertices. That's why while I less than n, I equal to, so we have for j equal to 0, j less than n, j plus plus. For each vertex, there are n adjacent vertices. That's why for j equal to 0, j less than n, j plus plus. If g of vi is equal to 1, indicates if there is an adjacent vertex. So how we say that there is an adjacent vertex of v? So if g of vi equal to 1 and visit of j is equal to 0. So if there is adjacent vertex and which is not instead, then push v of ij v of g of vi vj into the stack. So you have to push v of j into the stack. Then after pushing all, then so you have to pop v equal to pop. So pop is so by using pop function we remove the top of the stack. So after removing the top of the stack, then we can print v. Again we have the I plus plus. So this is the algorithm we are using for DFS graph traversal. So what is the algorithm we are using for DFS graph traversal is so actually This is the algorithm for DFS graph traversal. First of all, let us assume that there are n vertices. I am not visited any vertex of the graph. So first we have to unvisit all the vertices of the graph. So that's why visit of I equal to 0. So when you put visit of I equal to 0, indicates that the vertex is not visited. So initially we are not visited any vertices. That's why visit of I equal to 0. First of all, I will use first we have to print the first node. What is the first node? 0. That's why visit of 0 equal to 1. So we make it as v equal to 0 and I will print that node. So let us we have the n vertices while I less than n. So then push all its adjacent vertices into the stack. Let us assume that there are n adjacent vertices. That's why for j equal to 0, j less than n, j plus plus. So how we say that we have the adjacent vertex if g of I equal to 1. So graph is represented as an adjacent matrix. In the case of adjacent matrix, if the value is 1, indicates so there is an adjacent vertex. Otherwise, there is no adjacent vertex. So visit of Vj equal to 1 and visit of j equal to 0. That means if there is adjacent vertex and which is not visited, then push that adjacent vertex into the stack. After pushing all its adjacent vertices into the stack, I will take the top of the element from the stack, v equal to pop. So I will take the pop of the element, I will print the element, and I will increment the count value, I value. So because I initially I equal to 0, so for each time, so I will make it as 1, I equal to initial, I will make it as a 1. For each time I value is incremented. So this is the way we are using for DFS graph traversal. This is the algorithm for DFS graph traversal. So what is this? This is about DFS graph traversal. So like this we can traverse the elements of a graph by using this technique. So okay, this is about today's topic, DFS graph traversals. Okay.